Hello, welcome to my video. Today I'll be doing question 6 in 2018 Additional Mathematics 0606 2 to October November series. So there's a 5-character code, and then to be formed from 13 characters, where 6 characters are in letters and 7 of them are numbers, and each character may be used only once. Find the number of different codes in which no 2 letters follow each other and no 2 numbers follow each other. So there are only 2 cases we have to consider in this case. First, I will usually just draw out in this case we need to choose 5 characters from all this 13 characters. So I will first draw out 5 boxes to be filled in, and since there are no 2 letters will be together and no 2 numbers can be together, the only possible way that we can think of it should be that between each 2 numbers there will be a letter in between, and between each 2 letters there will be a number in between. So of course case 1 will be when the first one is started with a number. Notice that we only have 5 characters here, so if the first one is started with a number, we will have more numbers than the letter. As we can see over here, that we have no more numbers to be chosen in the password in this 5-character code compared to the letter. And because this is a case where sequence matter, where A, B, A, for example, A, 1, B, let's say these are the first 3 characters in the passcode, is different from B1A. Hence, when we notice that the sequence matter, we need to use permutation. So in this case, all we have to do is to first find out how many characters, how many letters are involved and how many numbers are involved. In this case, we know that only 3 numbers are involved, so all we have to do is to say 7p3 is to write down 7p3, where the sequence matter, and out of the 7 numbers over here, we only choose 3 of them, and multiply by 6p2, where there are 6 characters to be chosen. And because the order matters again, we use permutation, and we only need to choose 2 from the 6 letters over here. And when we multiply them together, we'll get 6,300, and there will be the numbers of different codes if the first one over here is a number. And the second case will of course be when the first one is a letter. When the first one is a letter, there will be more letters than number. So there will be 3 letters involved and only 2 numbers inside this 5-character passcode. So all we have to do is, again, notice there's only 3 letters to be chosen from the 6, so we put out 6p3. We always use p in this case. Remember, you don't use the wrong you don't use combination in this case. It's important to notice that the order matter, and multiply by 7p2, where there are only 2 numbers involved, and we have 7 numbers to be chosen from, and there will be 5,040 cases in this case where the passcode is started with a letter. So when we plus them together, we will have like 11,000 something, and this is how you should approach this question. To get all 3 marks, you need to either write down this equation, and this equation will give you another mark as well, and your final answer will give you your final mark. And we move on to part B. A netball team of 7 players to be chosen from 10 girls. 3 of these 10 girls are sisters. Find a number of different ways the team can be chosen if the team does not contain all 3 sisters. So my way of approaching this question is, of course, I love to draw, I love to do like a branching like this, so it's more clearer to me that there are 3 sisters involved, and 7 other girls where we don't really have to, where they do not classify them into like any specific things. So all we have to watch out is the 3 sisters over here. And we have to watch out, another thing is that here say, we need to find the ways where the team does not contain all 3 sisters. Which means there are 3 different cases where the first cases will be, there will be no sisters involved, none of them are involved in a team. And another case is, of course, only one of the 3 sisters will be involved, 1 out of 3. And of course the last cases will be 2 out of 3. We cannot have 3 out of 3 because here is really clearly stated that we cannot have all 3 of them together, but we can have any one of them inside the team or any 2 of them inside the team. So of course, start with case 1 where none of the sisters were chosen. All we have to do is to use combination over here, because notice that it's to be chosen from, they are not lining up, so the order doesn't matter. So we only have 7, we just as we calculate 7C7, in another word, we just take all the other girls over here. We don't want any of the sisters involved in the 7 players team. So of course there's only one way to be to form this kind of team, and this is the only way where all 3 sisters, we just have to exclude all 3 sisters. And it's pretty straightforward actually, but as we move on to case 2 where one of the sisters were chosen, notice that one of the 3 sisters, it could be any one of the 3. So you mustn't forget to use 3C1, where 3C1 will actually give you 3, because it's important that because there are different people, even though they are all sisters, but any one of them to be chosen will end up having a different team. And then when one of the space is occupied by one of the sisters, the remaining spaces over here will be filled in by the 7 other girls. So out of the 7 other girls here, we choose 6 of them. So all we have to do is to multiply 3C1 by 7C6, and then we will get 21 in this case. And that's the number of ways you can form a team in a case where only one of the sisters were chosen. And of course the last case is that only 2 of the 3 sisters were chosen. Again, similar to case 2, but this time instead of 3C1 we put 3C2, because out of the 3 sisters we can only choose 2 of them. Multiply by 7C5, where we only left with 5 spaces to choose from. Notice that because 2 of them are occupied by 2 of the 3 sisters, and we have 7 people, 7 other girls to be chosen from. And in this case we have 63 different teams that can be formed, where each teams involve different players, or they are slightly different. And as we add them up together, we will get this answer 85. And this is how you should approach this question of 3 marks, where 1 mark of course awarded for your final correct answer, and another mark for your equation, this 2 equation. Of course another important mark will be awarded for the cases where 2 of the 3 sisters were chosen. And this is how you should approach question 6 that involve permutation and combination.